Alright, take a look at this AP question.
Is this
That's more than half the classes, but I'm so. I don't know what you're talking about. I don't have head. I can't watch the end. I don't even know how to do it. Subtitles. You guys are my words. Hey, Mia was taking
to the nearest 7? What is the total?
I made it 2 weeks longer than Mia.
Okay, do we just integrate this?
You can try.
Oh no, I would need a calculator to integrate this.
Yes, this is a calculator question.
Here you go.
Yay! What?
Why did I do Oh, I
That was the plan, to give you a take-home test tomorrow, but we're probably not going to be where I hoped we would be, so.
Why is that a good thing?
Either we're not going to rest, we're not going to
Is the answer D?
I can't.
I don't know.
Okay. That's my work. Did you do the chemistry homework that we got on like Saturday?
Yes, I did.
I have it done, I think. So do you want it now? Yeah, it's okay. It's super easy.
I only have 19 hours.
Okay.
So I can't really call it.
Did we get an answer?
What do you need? I haven't got my slideshow. I haven't even
No,
looked at it.
that's not what I'm asking.
Oh,
B,
I
C, and D.
from it's a D. It is D as in
You
no.
don't have yearbook.
Not yearbook. You had to take a senior photo of the yearbook.
Yeah. Okay.
He just got it from that.
I want mine. I want to see what it looks like. Because I
So,
didn't take a shower that day.
This would be the integral from 0 to 60. This
So I'm
is a calculator question. This was on the calculator part of the test. If we plug this into the calculator, making sure that we're in radian mode, I think we get D in 821 gallons.
See, if this was on, I could do this problem.
Good. This was on the 2016 test.
See, some days I feel like I can pass this test, and other days I feel like I'm so lost.
When I did the practice AP that he gave us, I was like, oh my gosh, I know all this. I'm going to pass this test. And then as I progressed through it, I was like, wait, I don't know that one. And then I got half, like, all of it done, and I was like, I did not know how to do, like, 3/4 of that. I was like, really? All the multiple choice ones were fine, it's just the freeze.
Sharon guesses right a lot. See, like, there's no art to guess.
No.
It's just like, yes, but if he's lucky and it's right, that's good for him.
But that
Alright,
is brain power.
let's take a look at the homework.
Yeah. I don't have to do it. Okay, I'm gonna.
You just sighed. That was a big sigh.
Oh my gosh.
But yeah, so you would solve for X for the Y thingy about?
Yes.
Okay. Good, give me consensus. I find it consensus.
What questions do we have on the homework here?
You answered
6.
Number 6.
Why 6?
Because I could not do that one.
Alright. So we've got square root of x. So
I didn't.
something like this. Plus y equals 0 and x equals 4. So we're taking this region here and revolving it about the x-axis. So the radius of my circle, right? Because remember, every time we take a cross section of this, it'll be a circle. Will be just the distance between square root of x, and the x-axis. So my area function would be pi times the square root of x squared, pi r squared, which would just be pi times x. So to find the volume then, I integrate from 0 to 4 of this function. So I put pi out front, it's just x dx. So then the antiderivative is 1/2 x squared, evaluated from 0 to 4. If I plug 4 in, I'll just make that pi over 2 times 4 squared, minus, if I plug 0 in, I just get 0. So we get 8 pi, which hopefully 8 times pi is about 25.133.
Okay. See, I didn't complete it. I just kept it at this page. Because I would have a calculator and I would.
No, this would definitely be a non-calculator question.
I know, but I didn't have this type of calculator and I was lazy.
Non-calculator question, so it doesn't matter what
Yeah.
calculator you had, you wouldn't be able to use any type of calculator.
Can we do 7, I think?
Sure. So, similar idea. We have our function is 2x squared, and my bounds, let's see, we've got the x-axis, and the line x equals 2. So, just have something like this now. I'm taking this and revolving this around the x-axis. So, my area function would be pi times the radius squared. Here the radius is just 2x squared minus 0. So 2x squared, which if I go ahead and square that, we would end up with 4x to the 4th. So pi times 4x to the 4th. So here I could actually pull the 4 pi out. Say this is 4 pi times the integral from 0 to 2 of x to the 4th dx. So take the antiderivative, 4 pi times 1/5 x to the 5th, evaluated from 0 to 2. So we just have 4 pi over 5 times 2 to the 5th power, minus, if I plug in 0, I get 0. So 2 to the 5th is 32. 32 times 4 is 128. So 128 pi over 5.
Okay, well, my picture didn't look like that, but
The pictures were all right.
let's just say my picture, I thought that was a Y, not an X, so I have a Y that it's just
So just for future reference, that's a 1.
shush.
That line doesn't go
Shush.
past there.
I had a really bad headache yesterday. I woke up from a nap. It was 7 o'clock. I got home, slept until 7, did my homework, went back to bed. So, do not question my logic.
Any other questions on the homework?
11.
11. So on this one, we are taking y equals x cubed. So that looks like this, right? The line y equals 2. And the first quadrant. So I'm saying I'm taking this space right here and revolving this around the y-axis. Okay, to revolve things around the y-axis, I need to solve my equations for x. So to do that, I would take the cubed root of both sides here. So I would say that x is equal to the cubed root of y. Okay, or that would be the same thing as y to the 1/3 power. So what I'm basically doing is just looking at this sideways, right? I'm saying that if I'm revolving around the y-axis, well, the cross-section, okay, the radius of my cross-section would be this distance, okay, the distance from the y-axis to my function. And that distance would just be y to the 1/3 minus 0. So the area of my cross-section, which is in terms of y, will be pi times y to the 1/3 squared. Pi times the radius squared. And y to the 1/3 squared would just be y to the 2/3. So, to find the volume of this figure, I'm going to integrate this function. My bounds would be 0 and 2, since this is the line y equals 2. I can pull my pi out front, so I'm integrating y to the 2/3 dy. So, my antiderivative, add 1 to the exponents. Okay. So this is my antiderivative, evaluate that between 0 and 2. So I'm plugging in 2, so we get pi times 3/5 times 2 to the 5/3. Yet again, if I plug in 0, we just get 0.
So with this, we calculator problem?
We can just leave our answer like that.
Sure. But if it was multiple choice?
If this were on the multiple choice section, it would probably be a calculator question. It would probably have this in decimal form.
Okay.
Feel okay with this stuff? Any other homework questions?
I think I'm understanding.
Sweet. Alright. Then today, we're going to throw one more little wrinkle in. Okay, so we're still...
Just as we're starting to understand it, you gotta make it difficult.
Well, yeah, if you understand it, we're not going to keep practicing it. We're going to move on.
I don't fully understand it. We just like understand it a little bit.
Just let's accept the fact that if I see one of these problems, I might get one point.
I won't say I'll never.
Oh no.
Alright, so this is just a visual of what we have been doing. Okay, we're taking some equation, some line, and rotating that about an axis, right? And we're creating a solid like this. Right? Today, what we're going to do is look at
It's asking you so just that we shouldn't be doing things.
Yeah.
there we go. We're going to take regions that look like this and rotate these about an axis.
I think I did this accidentally. Because of my one, I had like a hole.
Well, that's what we're going to look at today. What happens when there's a hole?
Because I did that on the one that I thought the X was Y and
Alright, so if I take a region that looks like this, okay, so if I want to rotate that or revolve this about the x-axis, okay, it's going to look like a donut, right? We're going to have a hole in this figure, right? So if I revolve this around the x-axis, we get something that looks like this. Yeah. So if we think about taking a cross-section of this, okay, and whenever we take our cross-sections, remember those are perpendicular to whatever axis we're revolving about. So here, if I wanted to take a cross-section, I would take a cross-section perpendicular to the x-axis. That cross-section is just going to look like a circle with a hole in it, right? So what we have been doing is just our cross-sections are circles. Now, if we have something like this, our cross-section is just going to be a circle with a hole in it. How would I find the area of this? Okay? Our goal is still to write a function that models the area of a cross-section. So let's say I know both of these lengths, right? We can call this one little r and this one big R. What's the area of this figure?
Well, we have to take the area of
You take the area.
we have the little circle, and then you take the area of this circle, so you have to subtract.
Okay. So what would that look like?
It'd be
Area squared minus
pi r, but big R, then minus pi of little r. So we can cross. Can we cross out the home? No. Okay. I definitely don't want to do
We
this.
can divide pi.
Divide pi. There is no pi. I don't want there to be a pi.
Alright, so I do not have a guided note sheet for you today, so take your own notes. Okay, you might want to start writing this idea down here. I know this is pretty awful.
The cross section, like, what is a cross section? What do I use a cross section for? Find area? Is that all?
Yeah, so what we're saying is if I integrate an area, I will get a volume. So what we're saying is wherever I slice this figure, okay, the cross section is going to be a circle with a hole in it, no matter where I take that cross section. Okay, I mean that the sizes of the circles will change, but it will always be a circle with a hole in it.
She's against donuts, okay?
No. Okay, nah. This should be.
Alright, so to actually do this problem, let's see, what was this? Negative x squared plus 8x minus 8, I believe.
I don't know how to do it. What do I do?
Just, you can't draw
I
that?
don't remember
Plus 8x minus 8, yeah. Did you say a crispy pencil?
Crisp.
Alright, so our two functions here, in this visual are y equals negative x squared plus 8x minus 8, and y equals x. So what we have been doing, okay, is just saying the distance from whatever function we're looking at to the x-axis is our radius. Okay, and then we're just saying our cross-sectional area is pi r squared and integrating that. Now we have to look at two different radii. Okay, we've got our big R and our little r. Our big R is the distance from the top function to the x-axis. And then our little r is the distance from our bottom function to the x-axis. Well, I mean, you don't have to sketch out the three-dimensional version if you're having trouble with that. Hopefully, sketch out the two-dimensional. Alright, so if I want to express one of these circles, okay, I'm going to say that my area function, my a of x, is pi times big R squared. So big R is this distance. Okay, so that's just going to be this function squared. So pi times negative x squared plus 8x minus 8 squared. Then minus pi times little r squared. And little r is just this distance, so that is x. Okay, so now to find the volume of this figure, we integrate our area function. Now, one other thing that we don't know yet is our bounds. How would I find the bounds? Right. We would set our two functions equal to each other. And now, this one is a little ugly to do by hand. Okay, it does not work out nicely to whole numbers. So we can use the calculator to do this. So if I set negative x squared plus 8x minus 8 equal to x, how would we solve that? Using the calculator.
Graph.
Sure. Graph. So what do we get for our bounds if we graph this?
Which isn't new.
You have another one right there. Because the batteries are low, it's needed dead. Use it till it dies. So,
Okay, so I have them graph, like, plug in. And then I look how everyone goes.
You get put frosting.
Yeah. So what was wrong?
stat plot turned on. Well, I mean, if we look at this picture, I mean, we're going from like 0 to 10 and 0 to 10. So to find these points of intersection, we would use Calc 5, so second trace. And then the fifth option is intersect. It'll ask you for first curve, second curve, and then a guess. So just try to get your guess kind of close to that point. It doesn't matter if it's right on it or not. So, where you, I mean, close to where you think the point of intersection is.
I'm still having difficulty.
Where's the
I don't know. I have plugged in.
Oh, because you don't have it turned on. You have to hit enter.
It's still not there.
It's still not turned on.
Are we? Should I do this on the board calculator? Are we having difficulties?
For some reason.
Yes. 5.562 for the second one?
You're squeaking there. Oh no, I'm squeaking.
So, for an intermediate step, it's probably a good idea to go out to a few more decimal places than just 3. Alright, then first one.
cleared everything, retyped in everything. Still not working. I typed it in again.
All right.
And it wasn't even there.
So these are our bounds, right? Our points of intersection. Then to get the volume of this figure, I'm just going to integrate this. I can factor a pi out of both of those things. So I can just pull the pi out front, say this is going to be negative x squared plus 8x minus 8 squared minus x squared dx. Now, once we'll take a look at AP questions, probably not until after spring break, maybe over spring break, not spring break, Easter break. But what we'll see is a lot of the time on questions like this, they will say set up, but do not evaluate the interval. Right? So a lot of times, this would be our answer, right? Just the setup of the interval. Because these can get fairly complicated and ugly. Okay? So a lot of times, they'll just say set it up and don't solve it. But if we did want to solve it, if this were a calculator question, we could just plug it into the calculator and get an answer. So what would we get if we evaluate this on the calculator?
I feel like you hate us. Or hate me.
I do not hate anybody.
Okay, strongly dislike.
I do not dislike anybody. Anybody in here? Yeah, 5.5615528. At least that's what you told me.
Yeah. I just didn't copy it down whenever I said it. I didn't copy it down.
I really want some cake since I'm doing cake.
Alright.
Yeah, because I'm like doodling a cake. It's helping me relax while I'm like stressing it out now.
I've never tried pictures of cake to reduce stress.
No, like I just doodle, and today I wanted to doodle a cake.
Okay.
And it's
got
always
121.9,
helped me.
but I don't know if that's right because this calculator's messed up.
121.49.
49.
Exactly.
Well, yeah, because if you round, it's 49.
Oh, wow.
494179.
Okay, it's something, so it's not an air ball. Wait, what?
Is that not what
Oh,
you
you didn't multiply by pi.
Oh, no, I did not.
So what do we get?
Okay,
381.69. If you press it
I did something wrong. I got it.
But see what we get here.
Yeah,
just in case.
Why are you assuming I'm right? I'm not right all the time.
Is it a bloody cake?
Yeah, I just don't have colors. Okay, pretty bloody. It could be a bloody chocolate.
No.
Graduation.
Those are like eyeballs.
When do our final report cards come in?
After graduation.
After grad. So you can
That
pick.
probably doesn't matter.
Not
No.
really.
Well,
We don't get it until after graduation.
Basically, what?
I got 381.685.
yay. That's right.
Oh, you're gonna. What I tell you? Oh
Always
yeah,
3 decimal
3
places.
decimal places.
Okay.
Mr. Fetch, my elbow bruised.
Okay.
Oh, you guys better do good. If I'm coming to see you, you better win.
I'm not gonna win.
You better
That sucks.
smack just.
All right. questions on this process so far?
Not yet.
Feel all right with it? So, I mean, the only new thing is instead of just pi r squared, we're throwing a hole in the middle of our cross-sectional area. So we're saying big circle minus little circle, right? Pi times big R squared minus pi times little r squared. All right? So let's do another example here. I'm just going to draw this on the board.
So this may or might not turn out.
So let's take our two functions to be f of x equals x and g of x
He
equals
just had a click.
x squared.
Like everything just clicked into place.
Cool. Alright, so let's do a few different things with this. Let's first just find the area enclosed by these two figures. Okay? Find the area. So this is going back a few lessons. How do I find the area between two curves? Yeah. So we're just going to take top curve minus the bottom curve and integrate that. So I need a few pieces of information to do that. First, I need to know what my bounds would be. So we set them equal to each other. And so x squared equals x. What would be the best way to solve that? Subtract the x over. And
Take out an X.
got an x.
X equals 0.
Yep, 0 and 1. So our bounds are going to be 0 and 1. Now, how would I figure out which function is greater?
X squared because
Right, plug in a value between 0 and 1. So if I take a half,
Just a half.
it's a half. That would be a fourth.
So that would be the one.
So this one's greater on this interval. So my integral would just be x minus x squared dx. Okay, so
This be like an extended response problem.
yeah, so I'm going to present this like a free response problem. Alright, so let's, just for time's sake, let's say this is a calculator problem. So what do we get if we plug this in the calculator?
Wait, 166. Really?
So I guess if we want to go with that, 3 decimal places, 0.167. Okay, so that's the area of this region. Okay, I mean, we didn't even have to see what that looked like to sketch this out, but if we did want to, then this would just be something like this, right? This region here. Now let's say part B says finds the volume of a figure with square cross sections. And the unvolumed figure with square cross sections with base between f of x and g of x. So we're saying, I'm taking this region right here, and then I've got squares coming out of the board to create some three-dimensional figure.
Okay,
So this is,
what is this?
yeah, this is the previous lesson.
Okay, so the sides is x minus x squared.
Right, so if we're thinking that the base of the square would be this distance, right? So I've got squares coming out of the board. So if I'm thinking about a cross section, well, the length of one side of the square is going to be top function minus bottom function. So x minus x squared. Right? So the area then of this square, right, x minus x squared squared.
Then you take the derivative, not the antiderivative.
Right, so we'll take the integral of my area function. And my bounds are still 0 and 1. Right? So 0 to 1 of x minus x squared dx.
Are we stating this is
Yeah, since we're squaring it, no.
So can we put the square and make it x squared minus x?
No. Because if we're squaring that, that's like this, right? We would have to multiply it out like this, and we would not just get x squared minus x to the 4th. If this were a non-calculator problem, it probably would be easier to go ahead and multiply it out and then take the antiderivative of each piece. But let's, again, for time's sake, say this is a calculator problem.
0.03.
0.0333.
Yeah, there's just a lot of theories. Okay, so part C.
Feel okay with this? All right, so now let's throw in some volumes of revolution. So let's say now find the volume if this region is revolved about the x-axis. So this is the new thing for today. Okay, so I'm taking this region in between these two curves and revolving it about the x-axis. Alright, so we're thinking this is pi times big R squared minus pi times little r squared. So my big R would be the distance from the top curve to the x-axis, and then my little r would be the distance from the bottom curve to the x-axis. So we said the top curve was x, right? So my a of x is going to be pi times x squared minus pi times x squared squared.
No, you can change that into x to the 4th, right?
Right, yeah, we could just say this is pi times x squared minus pi times x to the 4th. So now to get the volume of this figure, we integrate this area function. My bounds are still 0 to 1, right? And I can pull my pi out and just say this is x squared minus x to the 4th dx.
.418.
Is that what so I mean, we're gonna do one more part, and I would say this would be a full 9-point free response question.
Really?
Yeah.
See,
But, like, it's no good on our test.
I wouldn't be able to figure out the words and what they're asking.
Well, I mean, we'll look at more examples, and like actual examples from the AP tests. So for the final part here, let's say we want to take this same region now and revolve it about the y-axis.
So I'm the ball. Yes, I was writing down the questions.
Right? We will have to solve both of them for x to get them in terms of y. About the y-axis.
So why is that above and not around?
You could say either about or around. Yes, it actually will in this case. So we're basically just looking at this sideways now, right? So I'm looking at the distance from the y-axis to these curves.
So g of x is the opposite way ahead?
And also, whenever we're doing this about the y-axis, we need to put these equations in terms of y. So if one function is f of x equals x, well, that would also just be
Y.
x equals y, right? So I can say that this curve is x equals y, and then this curve
Is square root.
square root of y, right? If I take y equals x squared, solve that, I would get the square root of y. So now, if we're thinking about, well, my little r is the distance from x equals y to the y-axis, and then my big R is the distance from the square root of y to the y-axis. Okay, so here, we're thinking about pi times big R squared minus pi times little r squared. Here, my a of y would be pi times, we said big R was square root of y, so square root of y squared minus pi times y squared, which will just end up being pi times y minus pi times y squared. Now, do my bounds change? What?
It would, but I don't know. It's the same.
Yeah, so it would, right? We would need to consider these two functions now, the square root of y, and set those equal. In this case, however, it does actually end up being the same value. Right? If I set the square root of y equal to y, I will still get y equals 0 and y equals 1. Okay, so yes, we would actually have to solve this again. Okay, we would have to set the square root of y equal to y, but in this case, it works out to be the same values. So we will say this is the integral from 0 to 1, and I can pull pi out, and then just say y minus y squared dy. So if we're using a calculator, okay, I can just input all these as x's, right? It doesn't matter what variable you use when you plug it into the calculator. When you're writing it out, though, if this were an actual free response question, we would need to write out our work in terms of y. Okay, but when we plug it into the calculator, it doesn't matter what variable we use. So what do we get for this?
5, 2, 4. That's rounded up.
5, 2, 4.
Yeah, I got
6, 8.524.
Yep, you did.
Yes. So, I mean, are we feeling all right with this stuff?
Yep.
I do want us to practice a little bit.